CIRS was designed to be the most innovative and high-performance building in North America at the time of its construction. And it was also designed to be a living lab that allows research into future and current building technologies and also looks at the inhabitants and how they interact with those systems.
The idea here is to work with nature, not against nature. So use nature to be part of your passive design, to use less energy to achieve the same result.
So the design goal of CIRS was to create a low embodied energy and low carbon impact structure. In order to meet that goal, the designers determined that wood was going to be the best choice because it contributes to both of those goals.
It's a material with the lowest environmental footprint of the construction materials that exist there. So lowest embodied carbon, lowest embodied energy.
When you think about CIRS as one of the goals of being the most innovative and high-performance building, wood actually fit into all that criteria. It's one of the most sustainable materials in the world. It's made by the sun. It's innovative in its use in this building.
Some of the advantages of wood are it's easier to erect, lighter pieces, a lighter building.
Well, with the new technologies like CLT and LSL, which has been around a while longer, the technologies are becoming very competitive with steel and concrete structures. You know, large open areas that are being spanned without having to have columns in the middle of the floor, which is quite important for institutional buildings. Like in the CIRS building where you had a 400-seat lecture theater, and it can be done.
And seismically, wood buildings actually perform much better than concrete buildings would. They're lighter, they have more flexible connections that perform better in a seismic event.
One of the most innovative things that we did here related to the lateral system. The way this building was designed with two fairly long, narrow wings limited us in terms of the placement of shear walls. And so we had to resort to a moment frame, a wood-based moment frame. So that's where the columns and the beams around the perimeter act together to create a stiffness to resist lateral loads of wind and earthquake.
In terms of vibration and acoustics, wood can be designed to perform the same as or better than concrete or steel buildings.
The auditorium in this building supports a very thick green roof, so it's a very heavy load. There's a series of arched beams across the auditorium that support this green roof. And so what we did in the connection at the end of the arches, we provided a gap and slotted holes so that when the heavy loads came on the arch could flatten out and deflect and slide and not actually bear on the concrete support beams. One of the issues with the steel connections is that they are very sensitive to temperature in a fire, whereas the wood is an insulating material. And so if the steel is actually embedded internal knife plates in the connection, that protects that connection and provides a better response for under fire conditions. In this structure, we wanted to expose everything. And so there is a provision in the fire code for what they call heavy timber. So the procedure involves selecting a beam size that is slightly larger than what you need, and then allowing the char to take away that material on a fire and still have enough remaining that you have a safe structure. Once you remove the char, what's beneath it is perfectly viable wood. In this case, in this building, additional sprinklers were added above and beyond what was technically required by the code.
Our current understanding is that wood takes less energy and resources to manufacture into construction products than does cement or steel. And for every single kilogram of wood that you're putting into this building, you're sequestering about 1.8 kilograms of carbon dioxide equivalents. So we're trying to balance these two elements of energy use and carbon emission.
When you consider the total cost of ownership of a facility like this one, on a life cycle costing basis, your facility will provide better returns than conventional buildings.
In a building such as this, a wood frame building, the embodied energy is far superior to any other type of material. Wood is a natural material. As it grows, it takes the energy from the sun and converts it to carbon. And so that energy is in the wood.
So I think as we enter this space of sustainability, we have to start asking the tough questions, and that's where the research of a life cycle assessment provides a better structure for guiding those discussions through what people are concerned with.
CIRS is providing a really good precedent for how you can build a commercial building as defined by the code using heavy timber construction, engineered products like glulam and others to provide a perfectly safe, sustainable building that complies with the local codes.
We actually had to add more seating for students because of their enjoyment of the space.
People feel they're in a more comfortable building, in a bright and warm building.
So coming in here and seeing a building that's illustrating the beauties of nature, it's just phenomenal.